Hello everyone and welcome to this presentation on Fibonacci-like sequences. Today, we're going beyond the classical Fibonacci numbers to explore as a fascinating family of mathematical sequences that appear everywhere, from computer algorithms to the natural world around us. We'll discover how changing just a few simple rules can create entirely new sequences with unique properties and application. We have the definition of the Fibonacci-like sequences that follow similar recurrence relation to the Fibonacci, but with different initial condition on number of terms. Why study them? For their applications in computer science and combinatorics, natural patterning plants, animals, and crystals, mathematical beauty and generalization of golden ratios, connection to other mathematical structures, a whole family of number sequences we will see. The first one is a Lucas sequence. The Fibonacci's closest relative. Its definition is in here. L0 equals to 2, L1 equals to 1, and Ln4 equals to Ln minus 1 plus Ln minus 2 for n a lot greater or equal to 2. So the generated sequence is 2, 1, 3, 4, 7, 11, 18, 29, 47, 56, 123, 199, 322, and so on. So it's a lighted Fibonacci. Each term is the sum of ploys 2. The key properties include Ln equal to Fn minus 1 plus Fn plus 1 for all n greater than or equal to 1. And Ln plus 1 over Ln 1 and goes to infinity equal to 5. It uses in primality testing here. Its application to determine the Mersenne primes called Lucas-Zemer test for Mersenne primes. Check the number, the Mersenne number primarily testing. The second sequence is Tribonacci sequence, sum of three Ploy's terms. The definition is in here. T0 is 0, T1 equals to 0, T2 equals to 1, so Tn equals to Tn minus 1, Tn minus 2 plus Tn. So the generated sequence is 0, 0, 1, 1, 2, 4, 7, 13, 24, 44, 81, 100, 49, 200, 74, and 504. The properties, we can see the properties of the Tribonacci sequence. The Tribonacci constant we have although called psi approximately is equal to 1.839 to 86755. And although Tn plus 1 over Tn equals to psi 1 and goes to infinity. Already used in combinatorics and piling. Here we can see its application in graded tiling. The graded tiling pattern using the Tribonacci. We can see a beautiful pattern using the Tribonacci sequence. And also the third one is Tribonacci and higher order. Sum of k Ploy's terms. For k equals to 4, the Tn equal to Tn minus 1 plus Tn minus 2 plus Tn minus 3 plus Tn minus 4. And the generated sequence is 0, 0, 0, 1, 1, 2, 4, 8, 15, 29, 56, 100, 8, 200, 8, 401, and so on. Or we can define the Fibonacci for k equal to 5 and beyond. And although we can denote K in terms, K is the Fibonacci. That K is the Fibonacci is defined as if n K equals to sum of I from 1 to K, Fn n minus I K. And also the Fn K plus 1 over Fn J when n goes to infinity, it's approximately equal to 2 1k go to infinity also. Its application is in data structures. We can define the k array counter science that they use in databases and retrieval systems. And also another sequence called Padovan and Perrin sequences. The Padovan sequence defines bilayer and relation. We have the Pn equals to Pn minus 2 plus Pn minus 3. And B0, P1, P2 equals to 1. So the generated sequence for the Padovan sequence is 1, 1, 1, 2, 2, 3, 4, 5, 7, 9, 12, 16, 21, 28, and 37, and so on. Perrin sequences also is defined as Pn equals to Pn minus 2 plus Pn minus 3, and P0 is equal to 3, P1 equals to 0, P2 equals to 2. And the Perrin sequence and Padovan sequence differences is related to the initial value. The generated sequence though for Perrin sequence is 3, 0, 2, 3, 2, 5, 5, 7, 10, 12, 17, 22, 29, 39, and 51, and so on. Alright, their application is in architecture. Although they define the plastic issue and can define the beautiful modern architecture. Also, there is another sequence called Narayana's code sequence because it's related to the animal population model. The definition is n0 is equal to 1, n1 equals to 1, n2 equals to 1, n equals to n minus 1 plus n minus 3. The generated sequence is 1, 1, 1, 2, 3, 4, 6, 9, 13, 19, 28, 41, 16, 88, and 129, and so on. The properties is related to the cattle population or cow population. Each cow produces offspring after 3 years. And also limit of n plus 1 over n goes to 1.46557 when n goes to infinity. Here you can see also a graph about the application of the Narayana's code sequence related to the cattle population growth model. And another one under sequence is Catalan numbers. The definition is in these forms: C0 equals to 1 and Cn plus 1 equals to sum of Ci multiplied Cn minus I from 0 to n. This is different from the other sequences. The generated sequences is 1, 1, 2, 5, 14, 42, 132, 429, 1430, and so on. And the formula is Cn equals to 1 over n plus 1 to n choose n. And also its application is related to the binary trees. The binary trees is that one of most important trees in computer science. And also the general Fibonacci arbitrary initial value. We can form a generalized Fibonacci sequence. The general form is Gn equals to Gn minus 1 plus Gn minus 2 with the differential value G0 equals to A and G1 equals to B. So the closed form is Gn equals to A multiply Fn minus 1 plus B multiply Fn. For example, if A equals to 2 and B equals to 1, then the generalized Fibonacci is the Lucas sequence. Or if A equals to 0 and b equals to 1, then the generalized Fibonacci is the traditional Fibonacci. And although the Perrin number where the ratio is the Zeller ratio, here although we can see the application of the generalized Fibonacci. It can be used for the cryptography application. It uses to encrypt data. Yet you can see an image that is encrypted using the generalized Fibonacci. Here also we can see the comparison table for the different sequences. You can see this different sequences, the recursion formula, the start value, and the limit ratio. For the Fibonacci fn equals to fn minus 1 plus fn minus 2, a start value is 0 and 1. The limit ratio is the 1.6180. Lucas sequence is ln equals to ln minus 1 plus ln minus 2. The start value is 2 and 1. The Tribonacci includes 3 terms, tn minus 1, tn minus 2 plus tn minus 3, and the start value is 0, 0, 1. The ratio is 1.8393, and Tribonacci also is summation of 4 terms, and initial value is 0, 0, 0, 1. The limit ratio is 1.9276. Padovan is summation of Pn minus 2 plus Pn minus 3. Initial value is 1, 1, 1, and limit ratio is 1.3247. Perrin also is that similar to the Padovan with the different initial value and the same limit ratio. Narayana also is nn equals to nn minus 1 plus n minus 3 with initial value 1, 1, 1, and the limit ratio is 1.4656. And Catalan Cn equals to summation of Ci multiplied Cn minus 1 minus r. And start value is 1 and limit ratio is exponential. Each sequence has unique application in mathematics and nature. And although we are here, we can see that some real application of generalized Fibonacci. We can see in the algorithm design that in science and technology, in the nature, like the Fibonacci, traditional Fibonacci, in the mathematics for encryption and combinatorics. And here also you can see key application by sequence. The Lucas using cryptography and preliminary testing. Tribonacci in modeling and tiling. Padovan preliminary architecture and design. Narayana in population biology. Catalan in compiled parse and combinatorics. Here also this summary presentation. We can present the Lucas sequence Tribonacci, Padovan plane, Narayana, Catalan, and generalized sequence. Okay. Fibonacci-like sequence are nature's building block across all scales. Okay. Thanks for watching. If you enjoyed the presentation, please like, comment, and subscribe. See you in next video.